Welcome. In this video, we're going to go over the solutions to the 2017 SL Chemistry exam, Paper 1. Question 1 asks, which compound has the greatest percentage by mass of nitrogen atoms? I think it's a little misleading that they use the word atoms here when what they're talking about is mass. So you could look at how many atoms you have, and you see that in the first one you have 1 to 2 nitrogen to hydrogen, and the second one you have 1 to 3 nitrogen to hydrogen. But then the next ones you've got different atoms combined, so N2O4 and NaNO3, although I can quickly eliminate these two because O4 is much heavier than hydrogen, and sodium and oxygen are both much heavier than nitrogen. So nitrogen's not going to be nearly as big a percentage of mass with these two. So then it's really back to A and B. So looking at the atom ratio does tell me that A is going to have a slightly higher percentage by mass. Or you could look at the mass, this is pretty easy mass, 28 out of 32 versus 14 out of 17, and do your comparison that way. Number 2, which statements about mixtures are correct? The components may be elements or compounds. That's true. That's what substances are, is elements or compounds, and you just physically mix them together. All components must be in the same phase. This one is false. In fact, they're often not. We dissolve a lot of solids and liquids in our day-to-day lives. If you drink soda or other carbonated beverages, that's a gas dissolved in a liquid. And 3, the components retain their individual properties. That's also true. That's one of the characteristic features of a mixture, is that they've just physically mixed so each substance retains its properties. So that leaves us with 1 and 3 only, which would be B. Number 3, you have 5 cc's of 2 molar sodium carbonate added to a volumetric flask, and the volume was made up to 500 cc's with water. What's the concentration in moles per liter? So the first thing I need is all my volumes in liters, since they're both given in cc's. So I'm really talking about 0.005 liters times a strength of 2 moles per liter. So if I multiply those, that's how many moles I have. And then if I divide that by my new volume, which is 0.5 liters, that's really like multiplying by 2 if I want to make this simpler. So 2 times 2 is 4 times 0.005 is going to give me an answer of 0.020, or C. Number 4, what is the expression for the volume of hydrogen gas? And these are always a little bit tricky because it'd be easier just to calculate the answer, in my opinion. But if I read through, it's at STP, I have 0.30 grams of magnesium, and I'm being asked to find what's the volume of hydrogen gas. So the key here is I'm going to have to change my 0.30 grams to moles. So I do that by dividing by the molar mass of magnesium, 24.31 grams per mole. And once I have that, then I can multiply by the molar ratio of hydrogen to magnesium, which is 1 to 1. And then finally, I can multiply by 22.7 liters per mole to get my resulting volume. Looking at my choices then, B would match what I've come up with. Oops, let me get my... Number 5, in which set do all the species contain more electrons than neutron? Well, 14 nitrogen only has 7 electrons, which would equal its neutrons. Oxygen has 8 electrons, which would equal its 8 neutrons. Carbon has 6 electrons, which would exceed its 5. So what I realize is nitrogen and oxygen are going to have to be negative ions in order for this statement to be true. So that means B is false. C and D are both possibilities, the difference being that in D, they've made carbon a +4, so now it no longer has more electrons and neutrons, so C is my correct answer. Number 6, which electron transition in the hydrogen atom emission spectrum emits radiation with the longest wavelength? So the key here is to realize longest wavelength is would be equal to a low frequency. And when you have a low frequency, you have low energy. And the other thing to realize is it's asking being emitted. So that means we're going to be coming from a higher energy level down to a lower one. So B is eliminated. 2 to 1 is a good distractor because that is the biggest step you can take between two energy levels. But 4 to 1 would actually exceed that because now you're taking multiple steps. 3 to 2, so 2 to 1 and 3 to 2 are only covering a step each. 4 to 1 is covering all that space and more. So C would be the correct choice. Number 7, the full electron configuration of an element is given here. To which group and period does the element belong? So I need to look at the final here, 3p2. The 3 indicates it's in period 3, and the p2 indicates it's over on the right hand of the chart with 4 valence electrons, so it is going to be in group 14, making D your correct answer. Which oxide, when added to water, produces the solution with the highest pH? So we're looking for the most basic solution here. So again, I can quickly eliminate SO3 because it's going to form H2SO4 and become acidic. CO2 is going to form carbonic acid, which is also going to be acidic. So I've got my two bases. So Na2O, I can expect my metal to form a base. And MgO is also going to form a base. And even though MgOH2 has 2 oxides to it, NaOH is a strong base. If you remember the acronym I like to use, it uses what I call BLINK because it's barium, lithium, sodium, and potassium are the strong bases. And we use NaOH a fair amount. That should ring a bell that it's a strong base. Magnesium oxide, you should realize, is going to be the weaker one because it's commonly used in antacids, which means it'd have to be much weaker than the NaOH. So A is going to produce my highest pH. Number 9, which of the following substances, what's the most probable structure of this substance? So the key is that it's got poor electrical conductivity as both a solid and a molten or liquid, and it's got a very high melting point. So metallic lattice is out because it would have good conductivity in both phases. Ionic is out because it would have good conductivity as a molten substance. Polar covalent is out because it would have a low melting point. So even if you don't know what a network covalent is, you're going to come to it by reason of elimination. Network covalents, things like silicon and carbon, tend to form these network covalents with high melting points but no conductivity. Number 10, which two atoms form the most polar bonds? So you're looking for a large atom bonded to a small atom. And carbon and silicon are close in size, but silicon is going to be slightly bigger because silicon is got one extra period on it, goes to period or one extra energy level, 3 versus 2. And then fluorine and chlorine, fluorine is going to be the smaller of the two because it's higher and tighter than chlorine is. So my most polar, biggest electronegativity difference would be C, Si, and F. Number 11, which combination describes the sulfate ion, SO3 minus 2, also known as sulfite? And if I look at SO3 minus 2, I've got 6 electrons from the sulfur. I've got 6 more from each oxygen, and then I've picked up 2 electrons. So I'm looking at a total of 26 electrons here, which means I don't need any double bonds. I can single bond each oxygen and put a lone pair on the sulfur. So its electron domain is going to be tetrahedral, but the lone pair is going to crowd it to become trigonal pyramidal, and it's going to crowd that angle from 109.5 to 107, making D the correct choice. Number 12, which correctly states the strongest intermolecular force in the compounds below? So each of these forms some polar bonds. CH4 is just slightly polar, I mean like barely polar, but really it's about the shape. So CH4, I'm going to have 4 hydrogen bonds off of it. CH3, Cl, I'm going to have 3 hydrogen bonds and then the stronger Cl bond. Here I've got just a slight polarity toward each hydrogen, but it's going to be balanced or symmetrical. And then CH3, NH2, I'm going to have polarity occurring with the nitrogen being more electronegative. So the only one that's going to be a true symmetrical molecule with only dipole-dipole forces would be CH4. And if you knew that one, A is your, I'm sorry, not dipole-dipole, with London forces. So if you know that one, your choices are now narrowed down to B or D. The CH3Cl is going to have some dipole-dipole forces arise. And then to confirm that, over here, when you have nitrogen and hydrogen, that does lead to hydrogen bonding. So B would be the best choice. Number 13, here's another expression with the math. Which expression gives the mass in grams of ethanol required to produce 683.5 kilojoules of heat upon combustion? So the way I thought about this is that I'm given in the equation that 1 mole should produce 1367 kilojoules of energy, and I'm being asked to find how many moles produces 683.5 kilojoules, and then when I get that value, I'm being asked to change it to grams. So X moles would then be equal to, if I cross multiply 683.5, and then I have to divide by the 1367, and then to convert that to grams, I'd have to go ahead and multiply by the 46 grams per mole found in my ethanol. And so the expression that matches that would be C. 14 I thought was actually pretty easy. They give you the diagram here, enthalpy diagram, which gives the change for delta H. So I'm looking for this equation, which is really the result of this to this. So delta H1 is left as is. I don't have to double any of them, triple, half them, nothing. All I have to do is flip the second one and make that a negative H2. So A would be my correct representation. Number 15, in which order does the oxygen-oxygen bond enthalpy increase? So I've got H2O2, which is going to be all single bonds. I have O2, which is a double bond, and I have O3, which has both a single and a double bond. So my single bond is going to have the weakest bond enthalpy. My double bond is going to have the greatest bond enthalpy, and then this resonance that I have in O3 is going to put it somewhere between the single and double bond. So that would indicate that B, actually A is the correct choice here. I'm sorry, no, B is the correct choice. O3 should be in the middle. So H2O with the least with the single, O3 with the resonance, and then O2 with the true double bond. Number 16, catalyst. This comes up. You'll always see a couple catalyst questions on both paper 1 and paper 2. Copper catalyzes the reaction between zinc and dilute sulfuric acid. They give you the equation and everything, and all they want to know is why does copper affect the reaction? And it's how it always affects a reaction with the catalyst. It decreases activation energy. 17, 100 cc's of 10% HCl is added to the solution, and that is this dotted line here. So that's my 10% giving that dotted line. Which graph represents the decomposition of an equal volume at 20%? Well, once they say 20%, you realize you have twice as much HCl. So assuming that HCl wasn't already in excess, you are going to have a greater yield, and it's certainly going to be faster. So A would be the graph that denotes that. Question number 18, consider the equilibrium between these two reactants. Which changes shift the equilibrium to the right? So since it's endothermic, number 1, increasing the temperature, that will drive it to the right. Heat favors the forward reaction. Decreasing pressure, so I notice that there's more crowding on the product side, so decreasing pressure will cause a greater decrease in collisions on that side, so that's also true. Adding a catalyst, that never affects equilibrium, simply the reaction rate in both the forward and reverse direction. So A would be my correct choice. Number 19, which is an acid-base conjugate pair? A and B both look good, but if one is true, the other would have to be true, because in each case, you've lost two H pluses. So they aren't a true conjugate acid pair because there's another substance in between. H3O minus goes to H2O, goes to OH minus. I'm sorry, H3O plus goes to H2O, goes to OH minus. And the same thing with H2SO4. It's polyprotic, so you would take off one hydrogen at a time. So then we're left with C and D. C is going to be a donor, can give up that H plus. And H3O is also a donor. So I've got two acids there, not an acid-base pair. But on D, I do have an acid-base pair because the NH3 can give up the H plus, the NH2 can accept that H plus, or the NH3 can give it up and form the NH2. So this would be a conjugate acid-base pair. Number 20, which 1 molar solution has the highest pH? Well, sulfuric acid can be eliminated. That's going to be low. So again, we're looking for basic here. Sodium chloride is going to be neutral since it'll just be salt water. So the question is NH4Cl versus ammonia. And hopefully you will recognize ammonia, NH3, as a weak base that when you put it in water, you're going to end up with NH4 plus and then OH minus. So this is a strong possibility if you don't know what's going to happen with ammonium chloride. Ammonium chloride, on the other hand, NH4Cl, when I put it in water, it's also going to dissolve, but this is actually an endothermic reaction forming NH4 plus, which is weakly acidic, and instead of forming the OH minus this time, it's the Cl minus being formed, or HCl. So this one is definitely acidic as it forms, and I'm going to end up with an endothermic reaction or more of a cold pack reaction going on here. So D is my correct choice. Number 21, what is the order of decreasing reactivity of the metals, most reactive first? So if I look at each equation and assess what it's telling me, the first one, zinc metal bumps off the tin, so zinc is more reactive than the tin. The second one, copper trying to bump off zinc ions is not successful, so zinc is more reactive than copper. And then tin trying to bump off copper is able to do it, so tin is more reactive than copper. So based on this, I could actually combine these two. And then silver trying to bump off copper is not successful, so copper is more reactive than silver. So here's my resulting series. I think you also could have just looked this up in your, I'm going to say you could look up in the data booklet, but you don't have it on this paper. So using this process, then, I would come up with D being my reactivity series. Number 22, what is the oxidation half equation in the redox reaction? So I have to look and see which species are undergoing a change in their oxidation state. So S2O3 2 minus, I see that the oxygen's contributing a -6 charge. And this, I've got 2 sulfur then to make up that +4 charge. So you should come up with sulfur here being a +2 charge. 2 times 2 is 4. 3 times -2 is -6, which would result in a -2 charge on that ion. I2 is going to be 0. Oxygen is still going to be -2 on this side. So now when I have 6 of them, I have -12. I want a -2 charge, so I have a +10 for the 4 sulfurs. That's actually a 2.5, which is a little bit weird, but what I see is it's a loss of electrons. So this is my oxidation. Well, my iodine goes to a -1. So what's the oxidation equation? It's the S2O3 becoming S4O6, and there's only one equation that indicates that, and that would be letter C. 23, which statements are correct for a voltaic cell? Spontaneous redox produces electrical energy. That's why it's called a voltaic cell, because it's producing voltage. Number 2, oxidation occurs at the cathode. And if you can't remember if oxidation is at the cathode or anode, when you look at 3, you should notice these two contradict each other, because here they're calling the cathode negative, and here they're calling the cathode positive. It is true that electrons flow from the negative to the positive, but what they have wrong is that it's the anode that's negative and the cathode that's positive, so 2 cannot be true. So 3 is the true statement out of those two. 2 is not true. Oxidation occurs at the anode, the negative electrode. So looking at my choices here, B would be my correct choice, 1 and 3 only. 24, what's the order of increasing boiling points? So if I look at the substance given in A, that's going to be just London forces here. So this is going to be very weak, C4H10, with just London forces. COOH, that's going to have London, of course, but it's also going to have dipole with the C double bonded O, and it's also going to have hydrogen bonds. So this one's got it all going. The third one is going to have just London forces, as well as the dipole is its strongest force, with the aldehyde there, the C double bonded O, or the carbonyl. And then this one's going to have its strongest force is going to be hydrogen bonds. So for sure C4H10 is going to be the weakest. So I've eliminated C so far. The second one should be my aldehyde, because it doesn't have a hydrogen bond and the other two do. So now I'm left with B. And so if we look at the order they put the hydrogen bonds in, it makes sense that the alcohol would be slightly less polar than the carboxylic acid. So B would be my correct choice. Number 25, what are the functional groups in the aspirin atom? Well, I see a carboxylic acid group up here, or carboxyl. I see an arene or phenyl group, which isn't one of my choices. And then I see the COOR group, which now I have to remember, is that an ether or an ester? And it is in fact an ester, because an ether, I remember, has oxygen with the same thing, with an R group or a carbon on ether side of it. So this would be 2 and 3 only, or letter C. Number 26, this is the ultimate shorthand way to draw a structure. What's the name of the compound with this molecular structure? You applying the IUPAC rules. Well, I see that there's 1, 2, 3, and 4 carbons in my straight chain, and then I have another carbon, a methyl group, hanging off of here. And because the carboxylic acid group, the carboxyl group, is always considered to be the end or the caboose, that would make this 3-methylbutanoic acid. 27, which molecule has a tertiary nitrogen? If you need to, go ahead and draw these out, but if you look, I've got only 2 carbons in this one, so that can't be tertiary. In this one, I have 4 C2H5 carbon groups that seem to be surrounding the N plus I minus. So that seems unlikely. That's a lot of carbon there. Then I've got C3H7 and CH32. So this one seems to indicate that I have a branch coming, the N, and then I have 2 methyl groups off the end. So this looks like a strong possibility. My last one, I have C6H5N, so that appears to just be a carbon chain with just the N at the end, and it's got 2 hydrogens on it. So looking at what's bonded to the hydrogen, or to the nitrogen, is kind of my key as to whether or not I have a tertiary group or not. So C would be my best choice. 28, what can be determined about a molecule from the number of signals in the hydrogen 1 NMR spectrum? Hydrogen's right in the name, and that's your clue that it's the number of hydrogen environments. 29, what is the density in grams per cc of a 34.79 gram sample with a volume of 12.5? Seemed like a pretty easy question for so late in the exam, but you have to remember that, oops, not mass over density, that density is mass over volume. So then 34.79 over 12.5, even without a calculator, you narrow it down to these two choices. So what's the difference? The number of sig figs should be limited to 3. So now I'm down to D as being my most appropriate choice. And number 30, what is the index of hydrogen deficiency for 1,3,5-hexatriene? A couple ways you could do this. You could recognize that 1,3,5 is telling you that there's 3 double bonds, which could each be saturated and give you an index of 3. Or using my method, if you just drew it with the 6 hydrogen or the 6 carbon and saturated it with hydrogen and count them up, you would see that the saturation takes 14 hydrogen compared to the 8 given, which means you need 6 more hydrogen or 3 H2 molecules. Either way you think about it, B is your correct choice.